Good afternoon, everyone. Thanks for joining us today. Um, Happy to have this digital event today introducing Enscape Impact. Um, give a little bit of a structure around what we're doing today. So do intros briefly, and then we'll have presentation, and then we'll have Q&A going and chat going during the presentation. You can ask questions there, but we'll hold all answers most likely to the end, where we'll have official Q&A session um, to answer hopefully all of your questions. Quick intros. My name's Corey Rubidoux. I run ArcVision, and we have Kelsey here from the ArcVision team, our sales operations manager, here to help support and answer any questions and keep the technical things running on the back end. And Sam Anderson's behind the scenes as well, helping keep things rolling as well. And then Roderick Bates joining us from Chaos today to give this presentation. Just a little bit of background on Roderick. Roderick joined Chaos in 2021. He's the director of corporate development, where he collaborates with product and R&D leaders to assess new product development opportunities and strategies. Before joining Chaos, Roderick was a principal at Kieran Timberlake in Philly. He was part of the Kieran Timberlake research group, using ecological, economic, climate, social, and site data to derive and inform sustainable design at their practice. Rod, happy for you to join us today, and excited to have you present this amazing new add-on for Enscape. We're excited to have you join us today.
Oh, thanks, Corey. I appreciate it. I'm definitely happy to be here. Should I go ahead and take it away?
Absolutely.
All right, well, let's get started right into it. And thank you for the introduction. The only thing I would ask next time is maybe you start with some intro music for me. I think that would make it even extra exciting. Something motivational, like a boxer in a ring. So
Actually, I'm doing James Brown next time. That's all I'm saying.
perfect. All right. There's a little bit of backstory there. Maybe we'll answer that in the Q&A. So this is the agenda that we have here. The first one is kind of the why. Why is chaos doing this? I think that's a question that we get a lot. And it's always good for people to understand our logic, our thinking, and really what the driving vision was behind Enscape, our impact, Enscape Impact. And then we're going to do a little demo. The challenge, of course, with live demos is that they're always boring and don't always work. So I have a nice little recorded demo that I know works, but it's the real tool in action. And then we have under the hood. I think after you see the demo and a little bit of background, a lot of people are going to wonder, sorry, hold on a second. What witchcraft are we performing in order to be able to deliver what impact is capable of? And so we want to show you what's happening under the hood, give you an explanation of the calculation methodologies and the nuanced detail that actually underpins what's happening within impact. And then, of course, what's next? Yes, Impact has just launched, but we have an eye towards the future. So we're going to share what's happening next, both from a perspective of new features, but also core improvements. And then, of course, the live Q&A. So let's really start into that question about the why, this idea of democratization of building performance. So one of the key things that we found out when we reached out to thousands of people around the world, primarily city dwellers, is that they had a lot of concerns about the environment. They feel that the environments that they're in are starting to show certain levels of extremes when it comes to the climate, and those are impacting their quality of life. It's not just uncomfortable, but the costs of living are starting to assert economic pressures that really make it hard for them to enjoy the urban environment. And it highlights the magnitude of the global challenge when it comes to building performance. And so when you think about those types of issues, this massive urban issue, you're confronted with, well, what's the solution to a problem that really operates on a huge scale? And when you have a huge problem on a global scale, you need to have a solution that's also going to have global reach. And that's one of the amazing things that we at Chaos with our Enscape software have. We have a phenomenally large number of average daily users. It's a really surprisingly large number of 365,000 or so daily users of Enscape. And when you have reach like that, there's an opportunity to make a difference and to implement change on a scale that actually moves the needle. But in order to do that, you really do have to, as we say, democratize building performance. And what do we mean by that? We mean essentially that you're able to give the power of building performance simulation to every designer that's out there using Enscape. And what this means is that all of a sudden you are actually implementing change on a massive scale. So if that's kind of the why, maybe we should go into, well, boy, if you're starting with something that lofty, global change, maybe we should start with making an argument of why we think we're actually in a position to be able to do that. What do we know as a visualization company about improving workflows in such a way that you can truly democratize them? So let's go to year BE, or before Enscape, pre-2017. And in those days, I wouldn't say they were the dark days because people were able to do fantastic things with V-Ray, another one of our softwares, but at the same time, they were doing them in a separate track. They were doing a design documentation track where they were creating their building, documenting it perhaps in Revit, something along those lines. And then they would have a separate visualization track where they'd be using V-Ray to understand what that building was actually going to look like. And there had to be a certain amount of data transfer across these two. They usually operated at disparate timescales. And there was a need to sync information at various intervals that caused a certain degree of inefficiency. And then behold, year AE, or after Enscape. And all of a sudden, you have a flattening of those processes, whereby documentation and visualization tracks can be folded into one. And the benefit there, of course, it's huge. Massive jump in efficiency. You have the opportunity to understand as you design what something actually looks like, and you have hugely improved communication throughout all the design. You don't have this lag between, okay, what's it going to look like, and this is actually how we're going to build it. And you actually have those two things within one particular track. So now we look at some of the other workflows that are out there that are still operating independently. So we go to year BI, or year before Enscape, or before Enscape Impact rather, and you had building performance analysis operating as a completely separate track. And it was one that was occurring essentially at a point that was not only temporally distinct from that of the design and visualization track, but it was also one that had multiple steps involved, where you essentially had to have a modeling, a building performance modeling, or actually a modeling of the building for the purposes of energy analysis. And then you actually had to run the analysis. And then you had to repatriate that data with your design track. Needless to say, just like was the case before Enscape, there was a lot of inherent inefficiencies, although in this case, even greater. And perhaps in many ways, the implications, at least from an environmental perspective, were quite a bit more severe. And so what we're here to present today is Enscape Impact, where we have done exactly the same thing with Enscape that we did for visualization. We are now doing for building performance, creating a single track where you can have design, visualization, and building performance all happening simultaneously. And that is how we propose to democratize building performance. So before you come up with a nice conceit like that, of course, you need to do your due diligence. You need to understand what the actual context was. What are the workflows that people were struggling with, essentially in this pre-impact world? And so, pulling upon my experience that Corey was kind enough to allude to, where I worked quite a bit in the context of building performance simulation on buildings that were both relatively small to extremely large, but also been talking to professionals at a variety of firms around the world. We found a high level of commonality in their experience, where in energy modeling was a process by which you essentially had a core design model, usually in Revit, something along those lines, that had to be converted into the appropriate geometry for ingestion by a building simulation or building performance simulation software. And in the course of that process, there was oftentimes a lot of assumptions and simplifications that had to occur that had to be verified, perhaps with the architect, maybe with the engineer. Oftentimes, there was a lot of phone calls that were happening. And then, of course, you'd run a report, generate your calculations, distribute those. That process in itself had inefficiencies, a certain amount of information loss that would be occurring. And then, of course, it all had to loop back into the design model. And throughout that entire fairly inefficient and laborious process, there were always challenges of communication. There was one in which the architect had their area of expertise. They understood plans, sections, they understood what it took to sort of document and deliver a completed building, but they didn't always understand all the nuance that the engineer brought to the table. And they certainly didn't always understand the type of data that the engineer was presenting when it came to building performance simulation. Or maybe if they did understand, they didn't always know how to act on it. And then you have the client who is caring about, well, how much is it going to cost to operate this building and what's it going to look like? And there wasn't a single tool that brought all of these different types of languages together to allow for easy, quick, and rapid communication. And the end result of this fairly fragmented workflow and sort of inefficiencies of communication was that you ended up having quite a bit of rework. You had a lot of data translation between the various stakeholders. You had a lot of modeling processes that certainly could be executed, but they weren't able to be executed easily. And of course, there was a lack of easy communication. A lot of information had to be taken, reprocessed, repackaged to be digestible by the various stakeholders. And the end result, of course, is you end up burning a lot of cash. And this really inhibited the proliferation of building performance. It kept it from being something that was really happening on a global scale. And instead, it was a niche practice that was happening on typically higher end or more significant projects. So with Enscape Impact, we were able to get from all of that initial data collection a very clear mandate on what this software had to do fundamentally in order to really democratize building performance. The first thing is that it had to be like Enscape. It had to integrate across all of the CAD platforms that Enscape does. So whether you're in Revit, Rhino, Vectorworks, ArchiCAD, all that sort of stuff, it just had to work. And it couldn't necessarily be different depending upon what platform you're in the same way that Enscape functions similarly, regardless of host platform. And like Enscape, it had to be easy to understand. This had to be the tool where, regardless of your previous experience in the world of building performance analysis and simulation, you could still get actionable data. Um, and of course, if you're going to get actionable data, it has to be data that you can trust. One of the things that people frequently asked us when we showed them some early prototypes was say, is this something that I could show my client with confidence? And we wanted to make sure that the answer was absolutely yes. And to do that, we partnered with a company called IES, or Integrated Environmental Solutions, out of Scotland, who has very much so a trusted and validated workflow in the world of energy performance. And then lastly, of course, the data that's generated has to be relevant. It has to conform to the types of metrics that users understand that are relevant to building performance simulation, energy end use, total energy consumption, peak loads, and then carbon emissions. So let's go through an exercise and say, well, what is it like to use Enscape Impact? How much do I really need to know? How easy to use do you really mean when you say it's easy to use? Well, let's start with some basic questions on a project, and I hope that most people working on an architectural project can answer them. First one is, where's your project located? So for this particular example, it's in San Diego. Then, what type of building is it? I hope you know what type of building you're working on. Maybe single family residential, maybe it's a hospital, maybe a dining, or a school and university. And then lastly, what year was it built? Or perhaps you're working on a renovation. So what year was it built and when was it last renovated? Or maybe it's being renovated today. These are all things I really hope if you're working on a project you can answer. And we figure just about any designer worth their salt and maybe even less than that should be able to put forward. So if you're able to answer those three questions, you're able to use Enscape Impact. So here you can see the example. We're dropping in San Diego as the location for this particular project. They're putting in the building type, school or university, and then the year it was built and last renovated. So it was built in 2015 and renovated in 2024. From there, you're going to be able to generate your initial analysis. And that analysis is presented in a nice little dashboard view, like you see there on the left: peak loads, total carbon emissions, energy use intensity, and energy end use allocation. And as you're modeling, as you would in Enscape, making changes in your Revit model, happily cranking along, looking at different options, you're able to have that data be updated, the energy performance data updated in the impact interface there. Now, of course, that type of little dashboard is great, but it isn't always the best way to really understand building performance, which can oftentimes be specific to certain areas of a building. Certain portions of your building maybe perform well and the design was great. Other areas don't perform as well. And so we integrated directly into the visualization, essentially the capacity to see the results. And so from there, you can easily communicate with a variety of project stakeholders, regardless of how familiar they might be with building performance metrics. So let's get to that other piece then, of course, about IES, our partner. So we talked to a lot of different entities within the space to see if they were interested in what we were trying to do. And what was rather fascinating is we were told by most people that this was not possible, far too complex, and would be nigh impossible to implement. And oddly enough, though, one of the most sophisticated outfits when it comes to building performance, IES, was perhaps one of the most enthusiastic people that we talked to, or entities that we talked to. And so IES has customers that are really designing some of the most significant buildings around the world, and also has, interestingly enough, services within the realm of building performance. We have one of the largest building physics analytics teams. So they really have a huge amount of in-house expertise. So a partnership with them brought not only the technical components when it came to the software, but also brought their know-how. And sort of their astute judgment, their experience when it comes to what is an appropriate tool for this democratization of building performance, the mass proliferation of building performance amongst architects. So what exactly is happening under the hood, and what were we able to do in combining the expertise of IES and Chaos? Well, this essentially is, as they say, how the sausage gets made, a simplified diagram of all the various components that go into Impact. So let's take a little tour through the various pieces and explain what the parts are. So the first one, of course, is the view that you just saw, that Enscape Impact interface. That's something that UI was developed on the Enscape side, and it was developed, of course, to align very much so with the Enscape UI. So it should be something that's intimately or immediately rather familiar to anyone that's already using Enscape, or and has sort of that ease of use that our users expect. Now, of course, you need to understand the geometry that is essentially being inputted into the analysis engine. That's something that Enscape is actually uniquely positioned to be able to pull quite effectively, because a lot of that data that's used for rendering purposes is also relevant to be able to pull geometry. And in addition to that, though, you also need to understand your rooms and zones within a building itself. That's one of the key inputs for an accurate building performance simulation. Oftentimes, people have to create hyper accurate models with no void spaces and very closed volumes and things like that in order to be able to accurately run a model within an energy analysis software. Needless to say, that doesn't conform with normal modeling practices, and really represents a significant hurdle. So we developed something we call Hestia. It's an internal code word for a voxel-based methodology for automatic room identification and zone creation. What it means is that you can model just as sloppy as you want, and we're automatically going to identify rooms and zones and be able to create with the overall geometry, essentially a cohesive input into the energy analysis engine. The next piece is the user data and something that we refer to as the IES data model and template. So the user inputted data, well, those are the three questions that you were able to answer, or at least I hope you were able to: San Diego, school, university, and the year the project was built. If you put that information in, it allows for the selection of a template file. And those template files are that are created and curated by IES, and it includes all the relevant information necessary in order to run an energy analysis. So if we were to look at some of the components that go into that, you have essentially a model translation engine that creates the full input package. So one side's the data model. That's the geographical location, the associated weather file. You also have the building information model spaces shading. That's gets the part I was talking about with Project Hestia that we had internally. And then you have the building envelope information, which is also coming from our geometry component as well. But that's also combined with components we refer to as the model template. And that's a lot of the things that are happening under the hood that people may not know, particularly early on in design, and are required for the type of rigorous energy analysis that's done via the IES analysis engine. So that includes various components like the lighting power density broken out on a room level basis, the occupancy profile. So how many people and when are they occupying that building, and what's sort of their thermal preferences. So, if it's a space where people are, say, more active or less active, things like that. The specifics of the heating and cooling system that you might have and the associated set points, things like that. So a lot of that information under the hood, it all comes from that template file that's generated by IES. So from the MTE, you're fed into the IES Apache simulation engine. And what that is able to do is a variety of analyses. Now, right now, we're focusing on energy. But as you can see, there's other types of analyses that are capable within Apache. So it gives us a nice little product roadmap when we think about the future. Yeah, so you put all of that in, and output is, of course, your analysis simulation that you just saw, which is then fed right back into Enscape Impact, where it can be viewed and acted upon. So that's the nice little step-by-step process. We'll go a little even deeper under the hood with some information that was actually generously provided by IES, so a little even more technical detail if you're wondering about how the actual functionality occurs. But let's do a demo. So this is a bit of a canned demo, but it is at one point it was in fact live. So you can say, well, this is really is a demo. And so in this case, you're seeing a project. This is one of our current demo files that we have. And you can see that we're doing a slightly different project location. We're doing this one in Germany. So obviously you can do projects all over the world. Our data set is quite robust, and doing a multifamily housing. So you can see we have other types of building types in there. And so right now, what you're seeing is the process of analyzing this model and creating the geometry and room zone package that'll be an input into the MTE and then into Apache. So you can see it takes a little bit of time to run this overall analysis. Part of it, of course, is on that room and zone identification. Part of it is on Apache, and then part of it is feeding that data back into Enscape in order to represent both the dashboard view and then that more immersive visualization within the render view itself. So here you can see the data outputs from that analysis. And with this one, you can see you can obviously, you're still in Enscape. You can still navigate this particular model. And as you would say, navigate it, you can have this other type of view here where you're looking at the building performance simulation. Now, from this particular view, though, maybe you want to switch back and forth. So you're looking at a render view. You say, well, this is great, but maybe what does it actually look like? Where are the certain rooms that may be consuming more energy or less energy. Where do those look like? So, or what do those look like rather? So right now you can see we're able to switch right into that false color view, as we call it. And then you're able to select the various types of impacts that you want to look into, and then you can navigate, move around your building, and of course from this, share with other audiences, maybe have a screen capture and things like that if you want to put this directly into a presentation. So it provides really this nice 1-2. One, you have this dashboard view, the other one, you have this immersive view. So depending upon your application, maybe you do both, maybe one or the other, but it creates a fairly effective way of understanding how your building performs. So now the next thing that we wanted to demonstrate was how does it look if you want to make changes to your project? What does that process look like? So here we are in Revit, and what we want to do is basically make some more significant changes to the overall building geometry. In this case, we'll be adjusting the floor to ceiling height, essentially making the building taller all around on all the various floors, but to varying degrees depending upon which floor we're talking about here. So being Enscape, of course, we're doing this update here on the left and to the Revit model. And once that's synced within the context of Revit, you'll see the geometry being adjusted both in the Revit model, but then you'll see the render, of course, updates. Now, once that update happens, because we already have Impact Launch, it automatically goes through the process of reprocessing to reflect the results given the model changes that you've implemented. So once again, you're getting a sense of how long it takes. Some of our marketing material, frankly, called it real time. It's like, well, maybe not real time quite in the Enscape sense. Certainly real time in the sense of building performance simulation, where you might be waiting months, weeks, what have you, to get results back from your engineer. But it's certainly not real time quite in the sense of visualization. And part of that is it's just the significant amount of calculation that's required in order to display the results within Impact. But in this particular case, you can see if you look at, say, the energy end use and our megawatt hours per year, it went from 562 to 871. So making it pretty easy to say, okay, here was a design change, basically a fundamental change in the overall massing of the building. How do we implement it in Revit? No surprises there, of course. But then you're able to see what it looks like aesthetically in Enscape, and then, of course, what the performance implication is as well. So let's go to that other part then, under the hood of Impact. So this is something that IES presented, and I will do my best and do them justice. But I think let's start with the idea that we're talking about building performance simulation. And I think that's really the key piece here. That is what IES does. It's what they're known internationally as true experts in, but that's also what Impact is doing. Impact is doing all these things essentially behind the scenes because we are leveraging the same analysis engine, the same analysis inputs as the IES VE software. So we're talking about essentially a complete virtual representation of a real building that includes all the various physics-based processes of heat transfer, both into and out of the building. And then it's also one that is predicated upon the weather for a specific region. And it includes all of the types of air movement, whether it be infiltration, convection, infiltration, what have you, that's occurring in the context of an actual building. So when we look at the various components here, the first one is to think about the data model itself. This is where Impact connects with the MTE or the Model Translation Engine API, and it's sending there that specific data around the geographical location. So we're able to read with your input where that project is located. And what's great about that is that gives you a couple of things. Not only does it give you the associated weather file, but it also tells you what template to pull when it comes to the relevant building codes for that particular region. Or what building, if there isn't necessarily building codes for that region, what are typically the requirements via code for something in that climatic region. Then along with that, we have another container for the geometry. that overall shell of your building, the basic forms, and then the spaces, those volumes and zones, and then the shading objects within the context of what's being assessed, and then of course the values themselves that are being included for the purposes of simulation. Then you have the model template, and that's the piece there that is coming really from the IAS side. And this is something where it basically does their best match to for that type of building from their data set. And they have an incredibly robust data set of various templates that we are able to pull from. So you can see some of the types of pieces here, like infiltration rate. I'd really like to know what kind of architect knows the infiltration rate on a project during, say, pre-design or schematic design. They don't. You just be making it up. Fortunately, IES has a very good sense of those types of figures, and so they're able to put in these default numbers to start with. Same thing with occupancy profiles, or say the lighting power density that's required by code for that particular building in that region. So let's go into that template piece there. And I think for a lot of people, that's something that they want to understand more about and want to know what's happening there. So one of the key parts is that template is derived from the ASHRAE standards. So in the context of, say, most buildings, except for the low-rise residential, you're talking about ASHRAE 90.1. And to be able to look backwards, we're going all the way back to 2004, up to, of course, the contemporary standards. And what that allows for us to do is to be able to say, okay, what are the requirements if you want to hit code minimum, essentially, and saying, okay, that's your baseline by that region. And we only have a certain number of building types to start with. You can see we have several different dining options, hospitals, multifamily, office, school, and single family. And we're rapidly expanding that to bring in other types. And the reason that we started small is, of course, you have to start somewhere. And we wanted to make sure that this methodology was really validated before we started to break out into new building types. But the next version of Enscape they'll be launching early next year will already include additional building types, hopefully building out ultimately to a very robust collection reflecting that which can be found in the ASHRAE standards. Now, the other piece that's really key here that we're working quite closely with IES on is about a validation protocol. This is something where, like I said before, coming from chaos, we know visualization, but we're learning building performance. We have a great partner in our corner, but of course, within the larger industry, we have to essentially earn the trust of the practitioners out there. So we're engaging in a validation protocol that is comparing Enscape Impact to IESVE. And IESVE is a fully certified analysis engine, conforms to really the most rigorous standards that are available in the context of building performance simulation. So what's great is that it gives us a really nice internal benchmark, a really good sort of apples to apples comparison that we're able to do. Impact versus IESVE. And what's actually kind of unique, there's not too many other types of sort of architect-focused building performance simulation softwares that even have that as something that they can do. So you can see our testing approach that we have here, that we're basically trying to run almost every type of building permutation that we have in a number of different climate zones, and even a number of different types of geometry. So it's quite rigorous, and it occurs with every iteration of Enscape Impact that goes out. So you can see we're making adjustments to the glazing, the floor area, the number of floors, the climate zones, and the standards, running all of those things to make sure that we see very tight alignment with the IESVE outputs. So that testing process is something that's being done by IES. That's their bread and butter. They do that constantly for their own software. So we figured, well, it's probably appropriate that they do it for this one as well. But then there's also something where we're using those results not just to validate, but also to look for opportunities for improvement. And then that can then go into essentially bug fixes, enhancements, and things like that. And you'll actually see some of those that'll be coming out in our next release. And then as far as the metrics, so it's not just about the energy figures, but we're also always looking to improve that geometry interpretation. Our methodologies are quite novel that we have. And so we want to make sure that they're accurate as well. And so you'll see in just a slide or two some of the initial results that we have both on energy use and geometry, and how those are where they're performing today and where we hope they'll perform in the future. And then as far as expected outcomes, we have a target where we really want to see 5% or less variance between IESVE and Enscape Impact. So that means the variance between IESVE, which is your engineering grade software, like you literally cannot find a more sophisticated energy analysis software in the world run by the IES engineers and know it inside and out, versus Impact, we're entering in 3 questions, same project. We want to see less than 5% variance, which I think is just incredible when you, sorry, when you think that one completely through. And then, of course, we want to get those results out there. It's not just a matter of doing this and saying, well, I'm patting ourselves on the back as we make it better and better, but we want to share this with the broader audience. So our website will actually have this posted. I think we have some initial data already up there on the Impact website, which I'll have a link, of course, at the end. But that's something that we're trying to do to really build that transparency and trust. And then, of course, there'll be future updates, and we'll revise this protocol as we bring on more analysis capabilities, thermal comfort and daylight analysis being two that immediately come to mind. So let's go through an example. This is some of our first efforts at implementing this testing protocol. And it's one where, like I say, we're continuing to refine it. So we started off with some basic geometry from Impact, and then that geometry and basically from SketchUp is also generated via IESVE and then refined in both of them. And then we make a variation, in this case, adjusting the glazing by 10% and 25%. So the big question is, well, how does it perform? Well, out of the box, Enscape right now shows a variance of 12% between that and IESVE, which I think is pretty darn good. I would really be, I'd be hard pressed to say that there's any other tool out there that operates at this level of accessibility that is anywhere even close to that type of accuracy. But we still have a ways to go. So let's look at the other metric there. So I guess here's the energy piece. And of course, you have to go into some of the detail to understand, well, 12% is kind of like, okay, everything comes out in the wash, but what's some of the individual inputs that we're seeing? And we can see actually within that, some things work really well. And some things are not as accurate. Your heating is off by quite a bit. Equipment loads off by quite a bit. But some other things like say hot water, not so bad, lighting, not so bad. So there's really some great room for improvement. But it's interesting when you look at that overall figure, actually, that it's quite close, but the individual contributions can vary a little bit more. And then the other component there is around the geometry. And this is one where in some areas the geometry is really good. In some of them it's not. The roof area is pretty bad because a voxel-based roof, as you can imagine, is like a Lego roof, is not as good as a nice smooth roof. But fortunately, it doesn't seem to have much of an impact on building performance and all the testing that we've done. But one area that does have a bigger impact actually is in the context of external glazing. And so that's something where we've already done some significant sprints to greatly improve the accuracy of that. And that'll actually be coming out in the next version. So I look forward to perhaps Corey doing the same webinar again and showing how that particular metric is improved and our alignment is even closer. So the big question, though, of course, is how does this function as a design tool? If you're trying to do option A versus option B, well, then that's the real question, because it's not saying, okay, what is the total figure? Because oftentimes, you're operating off a real positive information early on in the design process around actual system details. But what you really want to know is I change aspects of my building, say like the floor to ceiling height, the overall geometry, the orientation, the wall to window ratio, things like that. What is that doing to my performance? And that's actually where the results get really exciting, where maybe we're at 12% variance in that baseline simulation. But if we change the glazing, say, we reduce it by 10%, both in the IESVE model and the Enscape Impact model, we're seeing a delta between the two of less than 2.5%, which is huge. Or maybe we reduce that glazing by 25%, and now you're seeing a 1.3% difference in the relative magnitude of variation between those runs. That's really exciting when you see something like that. And so what that shows is that when it comes down as a design tool, We're getting already really close. That baseline area, this is all from IES. This is their professional engineer assessment, is that the baseline's already in pretty good tolerance. Not so bad. There's still work to do. But if you're making design changes, the results clearly show that if you're going to move in the right direction or not. Is my design better because of these moves, or is it worse? And that way, in that functionality, IES, our impact rather, is just as good as IESVE, just vastly simpler and vastly faster. And I think that's the real thing, that users will know if the changes they're making are going to have a positive or negative impact, and approximately how much when it comes to their overall design. So from our perspective, we're really honing in on a very effective energy analysis tool for architects during the design process. So what's next? What are some of the general updates that we have planned? Well, first one is we want to improve some of the overall, just the redesign on the onboarding side, essentially making it just a little bit more intuitive for people when they get right into the software. We had some some users that very rightly pointed out that peak loads is one figure, and they said, "What is the point of that? We really need to have a peak heating and peak cooling." Sometimes when you're in the weeds, you lose sight of the big picture, and they're absolutely right. So that'll be coming out in the next release. And then another item that we have is, of course, that glazing accuracy improvement. We saw that even though the overall figures are pretty decent, there are some big opportunities there to improve the glazing performance. And that's something that is quite literally in testing as I speak right now. So really excited to see how that shakes out. And then the other one, of course, is adding some more detail when it comes to assembly types. So right now, you kind of get what you get when it comes to the inputs as far as assemblies and things like that for your envelope. But we want to give the users a little bit more control. So maybe it won't be sort of a complete menu of drop downs, but it'll be enough nuance so we can start letting them have their design be reflected just a little bit more accurately in the context of impact. And then some improvements on the cooling energy calculations. There are some issues there on the accuracy side that were noted. We're picking them up. So I think this really speaks to our sentiment of continual improvement, making this software better and better and being very transparent. And then, of course, features. It's not always just about those little improvements, but it's also about, well, what's next? So the first one is thermal comfort. So we're going to be able to have a methodology for predicted mean vote broken down on that room level basis. And that'll be happening in the first half of next year. And we're pretty excited about that because I think that is a metric that oftentimes architects don't get to consider in the context of their design, particularly early in design. So having a powerful tool that's available as they're making design decisions to understand comfort, I think is going to be a great asset. And then daylight analysis. This is something that I think from our perspective is particularly exciting because we think a lot about lighting, but we think about light from the context of rendering and visualization. The really exciting thing is that we're in the process of exploring using our own analysis engine, or I guess maybe not analysis engine, but our own ray tracing engine, V-Ray, getting that certified to be able to perform a daylight analysis in addition to using open source tools like Radiance. So the idea is that we can perhaps provide something that's just as accurate, but just a lot faster. But of course, give the architects the choice to use perhaps the tried and true versus our software, which will be similarly certified, but just a lot faster. And that's it. That's the pitch. And so I hope all of you are sufficiently encouraged to go out there and give it a try. It's right out there. We have a 2-week trial. And we really encourage anyone to get their hands on it and give it a go. It really is that easy. You saw what it took to run it, and you also saw how accurate the results are. So very excited to share this with you and hope you get into it. Now, if you're curious about any of the resources I showed, the Architects of Change report, it's a fascinating read. How often do you get to talk to 4,000 people and understand what's stressing them out when it comes to urban living? And then, of course, Enscape Impact. And then we have a white paper that we worked on with IES. So if you're interested in a little light reading over Thanksgiving, I'd encourage you to give that a try. Oh, let's see. Sorry, I didn't mean to escape. There we go. Next one. there. And now we have the live Q&A.
Awesome, Rod. Really cool stuff. Really cool stuff. That lofty goal of hitting that 5%.
It's going to happen. I'm telling
Yeah,
you.
it's pretty impressive. It's really impressive.
Isn't it nuts? I mean, I just think of how much I would sweat energy modeling and all the nuance. And then basically by leveraging the expertise of IES and our know-how and essentially creating a very accurate importation of building geometry, you're able to get really close. I mean, not to say that 5% is nothing to sneeze at. I mean, that's, kind of that's the difference between a great building and an incredible building, but still
yeah,
not bad.
it's impressive, and I think in the encyclopedia set in the future there'll be democratization, and then this example in there. I'm sure of it.
You're sure of it? Well, I don't know if I want to take you up on that one, but I will say though that it really has the potential to do that. And that's one of the things I think is most exciting here is there's a lot of people that feel like they don't get a play in the context of building performance. That's an expert's game or that's only for big projects or for big budgets. And if you're running Enscape, you can do this. I mean, it's like literally it's three questions. I think anyone can do that.
Yeah, absolutely. We got a couple questions that are out here on the table here. Dave was asking, are you gonna, I think you addressed this already, but he was asking if you're gonna add additional building types in the future, science lab, diagnostic testing labs, and data centers, for instance. Are these on?
Yes, yes. Yeah, we are. I think with some of the types though, there's a little bit more challenges. Like say, I think labs is a good example, right? Is it a dry lab or a wet lab, for instance? And the energy consumption delta between the two is huge. So that's a little bit of a challenge because we're probably gonna, if depending upon the building types that we go after, you may have to ask for more information. The other piece is we mentioned 365,000 um, average daily users, and I I think that labs are really important and they're absolutely energy hogs. There's no doubt about it, but they don't necessarily represent a very large portion of our overall user base. So I would say absolutely they're on the roadmap, but it may be later. However, I will also say that people reach out to us and say something's important. I guess someone just did.
Yeah,
That carries a lot of weight. We
yeah,
may be a big company with a lot of users, but when we hear directly from someone, it matters a lot.
yeah. Answer calls in the order they're received, and if you keep calling back, we might answer faster.
It kind of seems that way. I mean, I also call it a Greek democracy. Like, if something gets enough votes, it doesn't matter who it's from.
Exactly.
It really actually usually gets implemented.
Yeah. Um, Dave was also asking, outside of the screenshots, are there any other ways to get the data out of the model?
So that's a really good point. There's two different pieces when it comes to the data. One is the output itself. We don't have anything yet, but we're planning on having basically a PDF export that includes the results. So yes, on that. But the other piece of data, though, that is important to us and particularly important is around that template file and allowing people to get that out so that they can interrogate the specific components that are happening under the hood. Like, is that really the system type that I think it should be having? That kind of thing. And one of the exciting things from our perspective is that if you're really fluent with IES VE and you understand that template file, it'll be very legible to you. And what we want to be able to do is create a workflow in which that template file can be exported, adjusted and manipulated by an expert user, and then re-imported to so that it more closely aligns with your project.
Hmm.
And essentially what that means is because we're using that same input as IESVE, you could have almost the same input to Enscape Impact because we're both using the same Apache engine. And so you can have a situation whereby you can really create an incredibly close level of fidelity between your Impact run and your IES run, even if you're doing sort of non-normative system types like, I don't know, a cogen system in the basement or like campus heating and cooling or something along those lines.
Yeah, interesting. Does the IES template take into account the materials such as color to show heat gain, i.e., black exterior versus white exterior? that a little too
Shoot,
far?
I don't know, honestly. That's actually I that I don't know. I mean, I know that does things like, your R value and your U value, but I don't know if it includes the color. I'm gonna have to make a note of that one. I suspect not. Um, but it might.
Hmm.
Hmm. I don't like being stumped. That doesn't happen often. Shoot, Corey. Can you give me some
Uh,
softballs here?
yeah, okay. Here's a softball. Let's see what this one does. Um, you know, having this all part of Enscape is great, and I know a lot about, the bigger story of chaos and the bridge and V-Ray and Enscape and all these tools working together and Vision coming down the line. Do you guys see this impact tool maybe infiltrating some of these other tools down the road? What does it mean for V-Ray or some of the other parts and pieces that you guys have in the just the overall software ecosystem?
So there's a couple of different things. It's not always trying to get it building performance simulation into all the other tools. Like for instance, I mentioned V-Ray. It's like, well, we can actually want to take the V-Ray ray tracing and use that as a lighting analysis engine. So there's that piece of it. But then the other thing that I'm quite keen to do is we have a VR scene file format. You mentioned the bridge, but sort of our evolution of the bridge is the VR scene file format or the V-Ray scene file format, and that allows for the model or your geometry, your materials, lights, cameras, things like that, to essentially go from anywhere to anywhere in the context of the Chaos software ecosystem. So you can export a VR scene file from Enscape and bring it into 3ds Max where you're using Vantage or V-Ray, for instance, or you can go to our new Envision software. And what's great about that is it really creates these very streamlined workflows where you're not starting from zero. You're starting from everything you did in Enscape, but all of those components can be upgraded into the higher quality versions that may be enabled within the other types of software. What I want to see is the ability for that VR scene export to also include the output results from Impact. So if you're creating a VR scene export from Enscape, where you have Impact installed and you've run an analysis, you can include that. And what that means then is that as you're, say, creating a more compelling narrative in the context of, say, our Envision software for a presentation to clients, you can include potentially that type of immersive view where you're really showing the impact in the model itself. So maybe you aren't trying to run an analysis in Envision, but you are using Envision and superior storytelling capabilities as a means of communicating the results to a client. So
Hmm.
in that sense, that's where I see a lot of the opportunities for integration. I don't always see about sort of the proliferation of analysis capabilities, but I certainly do see them in the ability to push results in different ways for the purposes of viewing and ingestion. And in the same way, you think of some of the types of capabilities that we have, say in Vision, where you have animation capabilities. When you think of other types of analysis, animation can be a really effective way of communicating results. Think of like occupant movement, for instance, and we have moving people and Vision. Well, is that also one in which it's not just, well, how do we create a more compelling looking picture, but how do we actually have that movement aligned with an actual output or an actual analysis output.
Hmm. Very interesting. Dave's got a follow up here. Let's see if this stumps you too.
Thanks, Dave.
Yeah, thanks, Dave. Uh, uh, would thermal mass systems where R values may not be great, but the efficiency of the thermal mass can outgain the overall R value? He's wondering if it's looking at the wall construction type and not just the code minimum assumption.
So the wall construction type right now is going to be it's not populated by any of the model data. I think that should be the key thing here. It's understood. And that's why this works across SketchUp, Rhino, Revit. So there was, at least when we were first starting to do this, a sense that, hey, let's do something that works in the context of Revit because we can pull all that great BIM metadata. But then we thought, well, if that were dependent upon that, it's not going to work as Sones in Rhino, and or say in SketchUp. And where are they early in design? They might very well be in Rhino or SketchUp. So The software functions by having that information within the context of the template file. And I think that gets to the point I was saying, the future improvements that we have planned for next year. You're giving a drop down so people can select, their structural type. And so it gets a little bit of data there that'll include something that'll have an impact when it comes to the overall mass of the building. Same thing with the context of the envelope. So right now, like I said, it's creating something that's, like I say, much more simplified in a sense. Um, but we do recognize the value of having that. And we're going to include some capability for that in the future, but it will never be as nuanced as what you would expect in a full-blown energy analysis software for, say, code compliance.
Yeah. So how much information can you take from the Revit file and inform impact?
Right
Um,
now, I mean, we were not taking any other than the geometry.
yeah.
Um, I mean, the upside of that, of course, is we're able to work across all platforms. The downside is compared to, say, a software that does pull that data, obviously you're going to be giving up something.
Yeah.
But in our experience in talking to a lot of firms, the number of firms out there that are using Revit to that capability is relatively modest, to be perfectly honest. Obviously, as you get to the more sophisticated firms, the proportion increases. But we think that there's other ways in which we could provide a higher level of actually one, like I say, a little bit more nuance on the inputs within the context of impact. But the other one is by creating a really streamlined workflow, both for that editing of that template file, that input file being one, and then the other one by just having the workflow that goes right into IESVE, where the engineer can take this model that started and then take it all the way to compliance.
Very, very cool. Very cool. Can you just tell a little bit about the structure of the software? Is it its own application? How does it work exactly?
Okay, so it's a plugin for a plugin. So it's a little bit of a Russian doll here.
Yeah.
Um, that being said, essentially, and it has its independent licensing that'll function. So you buy it as um, an add-in, and the license is going to be co-termed with your current Enscape license, which makes it really convenient. The license type, when it comes to fixed or floating, aligns with whatever version of Enscape it's installed with. I should mention the price right now, we're at doing an intro price, just as we get off the ground of 250 USD for a year. So obviously very accessible price point, which is one of our objectives here. You can't democratize something if you're charging outrageous prices. So as far as the integration goes, it is its own, it's already installed with Enscape. So if you have Enscape, it's already there. It's just kind of dormant. So trialing it isn't much of a deal. You can just go to that little building with the lightning bolt and let it rip.
Got it.
And just as people may be wondering, PC or Mac, it's currently PC only. Part of that is that that's the only place that Apache runs. So we're limited there. If the market starts to show a real strong demand for a Mac version, then we'll respond accordingly.
Got it. You mentioned Apache. I'll ask one more question. Um, any any web version of this? I know you guys have some web viewers and Chaos Cloud and stuff like that. Anything there where people can browse this stuff on the web yet?
There's no web version of Impact. Interestingly enough, there is some exploration maybe on the IES side for web capabilities, but that's of course its own software, not ours.
Yeah.
But I would always encourage anyone who is interested in the best when it comes to building performance to definitely check them out. I mean, it's great software. It's just ours is it's got a different point, and a different mean or a different intent. Um, but no web version and none planned at this
Okay.
stage. And it's the same as Enscape. It functions as a desktop app, and part of that is just by the nature of the fact that it's integrated directly into the host applications. So I guess unless they go to the cloud, yeah, we'll stay where we are.
Absolutely. Cool. Awesome. Hey, uh, no more questions. Thanks for doing this today. Really, really appreciate it. Exciting stuff. This is awesome to see what you guys have worked so hard on. I've seen early sketches of this stuff back in the day.
Yeah, there
Seems
was some early vaporware that we were
exactly.
teasing for a while just to
Yeah.
solicit interest.
Yeah. So congratulations. I know you put a lot of blood, sweat, and tears into this. So great work, and uh, hopefully we'll help you guys push us out there.
That's great to hear. Thanks, Corey.
Awesome. All right. Thanks, Rod.